Today we're going to talk about ratios and proportions. This section right here hopefully is a ton of review, and like I said, goes back to algebra pretty much. Jax, did you start?
Yep.
What is a ratio?
5 to 1.
Okay, so what is it?
Comparison.
So a ratio is a comparison between two numbers. That's how we normally did it. Now we're going to extend that too. So we're going to have to be able to do this with more than two numbers. How do you show a ratio? Fraction normally, right? So we write it as this. How else can I show a ratio? A colon, right? What's a colon?
Just 2 dots.
Two dots, right? And what else? You could do it as a percent, yeah. So you could take your fraction and turn it into a decimal, and then that decimal into a percent. And then you can use the word two. So any of these would be doing the same thing, right? Normally we're going to do this, a fraction still, and we want to make sure that we reduce. When I'm talking about a ratio, okay, normally I want to always make sure that you're comparing similar things. This means that they have the same measurement. Now, I can compare girls to the whole class because you're still all humans. Well, the majority of us are. Okay. I won't say that all of us are necessarily human in this, but
I'm super.
what I'm saying is you really don't want to make a comparison between two totally different things. And hey, and if you're going to make a ratio into two totally different things, instead of calling it a ratio, they call it a rate. Okay, so what's a common rate? Miles per hour. What else? Okay, kilometers per hour. How about you science people?
Meters per second?
Meters per second, it's all about what? Gravity, right? Kilowatts, okay, something like that. So that's a rate, all right? So again, a rate is a fraction, but a rate's comparing two different things. A ratio is going to compare two numbers that are the same thing, that have the same measurement, all right? It's a really big distinction between the two, okay? So, real simple here, in 1994, the median weekly earnings for men was $522, and for women it was $399. Write a ratio comparing the earnings of men to women. What does the ratio mean? So even though it's not men to men, it's still people, right? So we can still do this. So if we do men to women, we're just going to write what?
522 over 399.
And then make sure that we can, if you can, reduce it, right? Yes. Even if it's in the other forms, you should try to reduce. Okay? So again, you're just making a simple fraction and reducing it. Okay? Hopefully that's not anything complicated. The next thing they introduce here, and this might be something new to you, is called an extended ratio. So we're going to have two or more things being compared. This would be, this could happen in shapes. Angles of a triangle, for instance. Okay? They're going to give you a ratio and an extended ratio, something like this, where A, B, and C are all numbers, but they're going to give you it's something like this. So A to B to C, and these would be like different sizes. So like 5 to 2 to 1. It would be an extended ratio. Well, anytime that you get this extended ratio, you got to make sure that you're going to compare it to something that you specifically know. So for instance, if they talk about a triangle, what do I know about a triangle? Okay, there's 3 sides. Do I know anything about those 3 sides though necessarily?
No.
Maybe not, right? The only way that I would know about those 3 sides is if they told me the what of that triangle? The perimeter, right? So if they said the perimeter of my sides are 172, and then they gave me the ratio of those sides, I could use those ratios to figure out the actual lengths. What do I definitely know about a triangle is that all 3 of the angles will always add up to what? 180 degrees. And that's what we're going to kind of try to look at with this information. Okay, so it says, in triangle EFG, the ratio of the measurements of the angles is 5 to 12 to 13. So again, they would give you this as that particular extended ratio. And then it says, and the perimeter is 90 centimeters. Well, this is where it gets a little sticky. Notice here the ratio is given to you in angles, but then they talk about the perimeter. Can I make a comparison between those 2 things?
Yes. You draw a triangle.
From the angles to the perimeter?
Oh, and then on the sides.
Right? So I can't do the angles to the perimeter. So basically the second part where it says, and the perimeter is 90 centimeters, for this particular case, I'm just throwing that out. So if they say that the ratio of the angles is 5 to 12 to 13, I can compare that to what? 180. So to do an extended ratio problem, you're going to take your ratios and you're going to give each number its own variable. And it's going to be the same variable. If it's different variables, I can't do anything with the problem, right? Because I can't add or subtract different variables. So what do we know about the comparison or the relationship between the angles of a triangle?
We'll add to 180.
The angles will add up to 180, so the ratios of those angles will also do the same thing. And so then I just simplify. So what's 25 plus 5? We get 30x is equal to 180, and so what's x?
6.
X is 6. Now is this my answer? It says find the measures of the angles. So then I got to go back and I got to plug it back into my ratios then, right? So what are my 3 angles?
72.
18, 78.
18, 78. Don't forget your degree symbol. Okay? And then realistically, I can check this by seeing if I added all 3 of those up, they should add up to what again? 180 degrees or no. So then we could do the same thing as long as those ratios that they gave us said the ratios of the sides, because they gave us the perimeter in this one, right? Then we would take those same things, we would give them each an x, and it doesn't have to be an x, it can be any variable you want. And then set it equal to the perimeter if they're talking about the sides. So the perimeter for the sides, the angles will always be equal to 180 degrees. Make sense? Okay, so those are extended ratios. All right? Pretty simple, right? So what's a proportion?
Equation.
Okay, kind of. What's that equation tell you?
Percent.
2 ratios are equal.
It could. What'd you say, Jax? What are you reading up there?
I'm not reading it.
Oh.
2 ratios are equal to each other.
2 ratios
Basically.
set equal to each other.
Yeah, showing 2 ratios are equal to each other. Oh, that sounds very familiar.
Oh.
Okay?
Oh, look at that.
So, basically, a lot of times we say if I have A to B, I'm going to set it equal to C to D. All right? And we're getting ready to do the ISAFS test, remember?
What's that?
Remember
No.
that? Okay. So, we're going to talk about this. How do I figure out if this is true?
Cross
In anything, if I take the cross multiplications, meaning the diagonal multiplications, if AD is equal to CB, then you have a proportion. Or you just say yes. If they're not equal, you don't. So this is one way of doing it. The other way of doing it, somebody said earlier, I could turn them into percents. Zoe said. So if she turns these into both percents, the 2% should be the exact same number. So there's different ways of getting to this, but this is the easiest way. And again, this is just something kind of silly, but this diagonal that's going this way is called the extremes. And the diagonal going the other way is called the means. So again, on those ISAFS tests, if they would happen to ask you those two vocabulary things, that's what it means. The extremes is always the diagonal going top left to bottom right. The means is always the one going the other. Kind of a weird thing, but. So, what are other ways that I could see that if it's a proportion? I could do this every single time. I could turn them into percents. I could just simply divide them to see if the decimals were the same. All of them are basically the exact same thing. We're proving if it is or if it isn't a proportion. Okay? So, another portion of this assignment might be that, right? One report said there were 224 TVs per 100 households, and another said there were 336 TVs per 150 households. Do these comparisons form a proportion? So the first one, our first experiment, or the first magazine, for instance, did their study and they found that it was 224 to 100. Is that the same thing as the second magazine finding that they did 360 out of 150? So are those two fractions the exact same thing? So you do this and see if it's equal to this diagonal by multiplication. Or you reduce, or you just divide and see if your two decimals are the same. So what'd you get? Yes or no? Does this work? Somebody do this diagonal and somebody do this diagonal. Well, this diagonal is easy, right? 336 with two zeros. Is this one 33,600?
Yes.
Yes? So, if you find out that they're both 33,600, do those two fractions make a proportion? Yes. So that's all you're doing in that section right there. Again, seeing if they form a proportion.
Is this explained? Is that like we just show that? Right?
Yeah, and explain is me just saying, yes, I did the extremes and set them equal to, and they were the same thing as the means. Okay? Any questions there? So then we try to solve a proportion, right? And if I solve a proportion, this is what you did in algebra to find a missing link, right? So basically we're going to have the same proportion. A over B is equal to C over D. But one of those four spots is going to actually be a variable. And so basically we're going to do this same thing, but because there's a missing piece, realistically all you really do is multiply the numbers that are diagonal to each other and then divide by that third number. But essentially you're doing the same thing, right? So if I had this is equal to that, but one of those was a variable, it's essentially saying what I just said, right? Multiply these two and then divide by that third number. So we make it real simple. 22 over 30 is equal to, can't read the number, get it wrong.
14 over X.
Thank you. So then again, I'm always looking at the two numbers that are diagonal to each other. I'm going to multiply them together. So this diagonal right here has both numbers. I multiply them together and I divide by my third number. So somebody punch in 30 times 14 and divide it by 22. 19.09. And then make sure that you read the directions to see what you round to. Okay? Again, unfortunately, one of the major things that we're not very good at as a school is rounding, which blows my mind. But anyway, what's the first decimal place called?
Tens.
The tens, then the hundreds. If you're rounding to the hundreds, you only really have to look at what? The third decimal. Right? If the third decimal is 5 or higher, then you round the second one up 1. You don't care about the tens thing. You don't care about the whole numbers. The only time you care about all of them is if they're all 9s and they're all going up. Okay? But for whatever reason, we're not very good at this. Okay? Some of the ones that bother some people are if I have a quantity instead of just numbers. A quantity means that I have a variable and a number together. So I get x plus 3 over 8 is equal to 4/3.
Just cross multiply.
Thank you. So again, there's a couple different versions of this. Some people like to look at these and say, well, what did I do to 3 to get to 8? Well, that might be hard in some situations like this case. So again, all I'm doing is looking diagonal, and I'm going to multiply the diagonals and set them equal to each other. But when I multiply this diagonal right here, which we came back and called the extremes, it's 3 times x plus 3. I have to make sure that I multiply by everything in that quantity. And then I set it equal to the means, which is 32. And then I just do my problem. So again, I'm looking this diagonal, 3 times that quantity, and then it was 8 times 4, which is 32. When I have a quantity, I have to distribute. And then we're ready to solve, right? How do I get x all by itself? Subtract 9, what's 32 minus 9? 23 divided by 3. Again now, remember how I always kind of say I would rather have you leave it as a fraction and then just reduce your fraction? This would be one circumstance where it's okay to punch it into your calculator and get 23 divided by 3, which is what? 7 something? 7 2/3?
Yeah.
So 7.6 repeating? Okay. So again, make sure that you read the directions to see what you're supposed to round to. Alright? But if it has a quantity, just make sure, and they can do that both ways. So there could be a quantity here and a quantity here too, so you just have to do it 2 different times and set it equal to each other, and then you're bringing your variables together. Okay? Any questions there? Alright, let's do this one right here. If $1 US is worth 102.7 Spanish pesetas and a shirt costs $19.95 US dollars, how much does it cost in pesetas? Is that the right word? You don't use it anymore? Okay. What do you use now?
I use it at the gas station.
Oh, you use it. Oh, sorry. It's outdated. Why I want to show you this is this. We're going to do the first one where it says $1 US is worth 102.7. 1 is equal to 102.7. Okay? What I want to show you that's really, really important, this is dollars right here, right? This is my old pesetas. Sorry. And so now, when I set up my second one, it says a shirt costs $19.95 US dollars. Your label has to go in the same spot. Okay? So this one is dollars, so it's got to go on top. Okay? And then we would have our P down here. So what are we spending? Other people might do it like this, where they take the 2 US dollars and they might put them on top of each other. So they're making the fraction out of the same unit, right? Those were both dollar amounts. And then this $1 was hooked up with this peseta, so they put them across from each other. And then they don't know what that capital P is here. In either case, both of these are exactly the same thing because look at diagonally. I'm multiplying the same 2 numbers together. So all I want to really emphasize here is your measurement has to either be both on top of each other, so we had dollars on dollars, or they have to be across from each other. And then we just go back and do the problem like we just got done doing. So how much does my shirt cost in pesetas?
$2,048.80.
2,000 what?
$48.87.
Thanks. What's the symbol for pesetas? Or what was it? You never used them? You only use a euro? You know what the exchange rate of a euro is?
No.
One is 20.
It's
It's what? It is?
I have one in my green.
Alright, so questions? Any questions with this? Hopefully, again, this is a lot of review. This is a bunch of algebra. Okay? So, the rest of the time is yours. You still got about 15 minutes. So there's your problem.
What?